Good day. It is a pleasure to participate in such a fantastic event. Thank you for such an opportunity. Today I will discuss sustainable tourism and robotics. A study on sustainable tourism ensures that development meets the needs of the current society, without harming natural resources and leaving sufficient resources for future generations. The purpose of using robots in tourism is not limited to serving guests but also includes environmental supervision, transport services, tourist monitoring, and other areas. This study aims to create and test a model consisting of effective monitoring, situation analysis, routine and creative decision-making, based on organizational reflex and execution of actions. The study reveals the useful application of advanced automation in tourism to promote the well-being of local communities, preservation of cultural heritage, and protection of the environment, where it has been found that the flow of tourists increases as negative aspects decrease. The aim of the research is to investigate how robots can contribute to the development of sustainable tourism, ensuring that tourism activities meet the needs of current society, while preserving natural resources and leaving sufficient resources for future generations. Theoretical modeling is based on phenomenological laws, time irreversibility principle, functionality principle, essentiality principle, corporeality principle, phenomenal description principle, while computer simulation is performed using Spider, Python 3.8 environment, and applying functions that reflect model behavior or perform certain tasks. Sustainable tourism and robotics represent a transformative approach to the tourism industry, focusing on ecological balance, social equity, and economic viability. This research highlights the principles of sustainable tourism, which ensure that current tourism practices meet societal needs without compromising natural resources for future generations. The integration of robotics in this sector is explored, emphasizing their roles in enhancing guest services, conducting environmental monitoring, and facilitating transportation. Key findings indicate that anthropomorphic robots, which mimic human traits, are preferred by tourists and can significantly enhance the overall experience. The study underscores the importance of responsible robotic implementation to avoid negative consequences while promoting sustainability. By leveraging advanced technologies, the tourism sector can improve operational efficiency and foster a deeper connection with local communities, cultural heritage, and environmental stewardship. Ultimately, this research advocates for a collaborative framework involving stakeholders across various disciplines to create a sustainable tourism model that benefits both present and future generations. The role of robots is pivotal in achieving these goals, as they contribute to reducing waste and promoting responsible resource use while ensuring a positive visitor experience. Environmental monitoring is carried out. The information obtained by means of observation is analyzed. During the analysis, tourists, their movement flows, and the resulting garbage are distinguished. After assessing the current number of tourists and the movement flow and the locations of the garbage, a decision is made on the organization of garbage collection so that the place does not lose the interest and attendance of tourists, because garbage in the place of visit causes negative emotions for tourists. A tourist destination is essentially dynamic in nature, that is, it changes over time. Here we mean that the number of tourists is not the same and the amount of garbage varies. The complexity of garbage collection also changes. In one case, it is complex, because it is not desired to cause inconvenience to tourists during the visit, restrictions on view and movement, etc., due to the work performed. In another, it is routine work for which simple algorithms for performing the work are sufficient. Therefore, an organizational reflex is applied here, which performs the aforementioned function and can train the system and accumulate information that will be used in the future to make complex decisions. Robots' movement trajectory is generated using various parameters such as garbage amounts, obstacle amounts, tourists, movement time, and other random parameters. These parameters are generated using the NumPy library, and the trajectory is defined as a complex trajectory with an autoregressive component, sinusoidal fluctuation, and movement according to a stochastic trend. Object recognition is modeled by identifying a given object as a garbage or an obstacle based on certain criteria, e.g. if the amount of an object is greater than a certain threshold, it is considered a garbage, otherwise it is considered an obstacle. In this case, the moving average used is equal to 7. If the amount of garbage is greater than the threshold value, it will be considered a garbage and represented in red on the trajectory. If there is an obstacle, it will be represented in orange. When linked to the trajectory, the ecological footprint, and the amount of garbage, it evaluates and identifies whether there are negative aspects. According to the concept of organizational reflex, negative aspects are divided into routine and creative decisions. Decisions are made based on whether they are related to the large ecological footprint and, if so, a routine decision is made. Routine solutions may include standard action reactions, while creative solutions may include unique or alternative means. By linking environmental management indicators to the trajectory, the assessment of various factors and their impact on the environment has shown that as negative aspects decrease, the visitors' flow increases, so it is very important to make sustainable tourism development decisions. Computer simulation includes random data generation, motion trajectory modeling, and object recognition modeling. These components make it possible to simulate various situations and evaluate the impact of the tourism environment. The results showed how garbage and obstacles affect the movement of robots and how it can affect environmental sustainability. Computer simulation showed how robot moves along the set perimeter to assess obstacles, tourists, while collecting garbage in tourist destination. How the trajectory of the robot's movement changes in a dynamic environment influenced by tourist flows and garbage volumes. In addition, the interaction of negative aspects and visitor traffic is also evaluated. It is recommended to develop the model or conduct an additional research as follows. 1. Expand the model to include innovation processes. It could include introducing new technologies, improving processes, or encouraging creativity. Such a model could help to understand how decisions and behaviors change through innovation. 2. Examine sustainability indicators more deeply and create a model that allows you to accurately assess your sustainability factors. This would include not only the ecological footprint, but also the socioeconomic aspects. Thank you for your attention.